I will have to find this right.
Excuse me, sir. It's a problem. Carbohydrates. It's make it make.
This is not fine.
Find the
Right. Okay. Right. Okay. Right. We move to today's work. Now, we know what happens to food after we eat. That is what we learned. Glycolysis spreads people from transport chain. And right. Now we'll officially move into carbohydrates. So after that, we'll move to proteins, lipids, that side as well. Right. Carbohydrates. This is not something. This is something that is like familiar to us. So this is not a heavy topic. Don't worry. Right. Well, carbohydrates. Well, right. When it comes to our meal, you know that rice. So that's like our major food source, that is carbohydrates. Right. When it comes to carbohydrates, so if we go into the biochemistry side of carbohydrates, not only rice. So when it comes to the plant food, right? Basically, yeah, plant food, not animals. That is protein side. We are talking about protein side after this. Completely after this. Then plant food, milk, right? Milk actually contains not only carbohydrates, we have other substances as well, but carbohydrates in person. Well, now when it comes to carbohydrates, if we go to the chemistry side of that, elements wise, carbohydrates have carbon, hydrogen, and oxygen. Right? So the composition, elemental composition is different from nutrient to nutrient. So carbohydrates, this is CHO, carbon, hydrogen, oxygen. That is the composition. Lipids, another composition. Proteins, another composition. DNA, another composition. So this is how this pattern. When it comes to carbohydrates, we have carbon, hydrogen, oxygen, not any other element. Right? And carbohydrates, you know that rice, bread, glucose, lactose, a lot of carbohydrates are there. They are not equal. So each carbohydrate is different from each other. Right? So then, so that we can study easily, we categorize. That's what something that we always do. When something is one place, so big, we categorize them into small categories and then we start. Carbohydrates also the same story. It is so big, so we categorize them into several categories of starting. Well, carbohydrates, we categorize them into simple carbohydrates and complex carbohydrates. Right? Simple carbohydrates, complex carbohydrates. So we'll see what are simple carbohydrates and what are complex carbohydrates. Let's see. Right. Well, I already told you that carbohydrates, they have carbon, hydrogen, oxygen. So when it comes to the composition, there is a ratio. Carbon, hydrogen, oxygen. There's a ratio, regardless of how big the molecule is. Molecule may be like, so the long chain will say starch. So very long chain, but polymer chain. It could be like very long, but there's a ratio between the atoms. That is the ratio between carbon, hydrogen, and oxygen. That is going to be 1:2:1, right? One carbon, to one carbon, there are two oxygens, and there, sorry, one carbon, there are two hydrogens, and one oxygen. So that's the ratio 1:2:1. Whatever the carbohydrate, that doesn't change. Like, let's talk about the most simplest carbohydrate, that is glucose. You all are familiar with glucose, right? So even in glucose, that is the same composition. 1:2:1. CHO. That's a the composition. Well, well, again we categorize them as monosaccharides, disaccharides, oligosaccharides, polysaccharides. That's another categorization. Right. The most simplest sugar, that is monosaccharides. The most simplest one, glucose. Right, most familiar one. The polysaccharides. Disaccharides, the simplest form of carbohydrates is what we call monosaccharide. So if somebody asks, what is a monosaccharide? That's the most simplest form of carbohydrate. There's nothing simpler than that. If we further break into something else, then it's carbohydrate anymore. Right? As a carbohydrate, for something to be called as a carbohydrate, it must be like, it can't be simpler than monosaccharide. The simplest version is monosaccharide. Right? Okay. So number of carbons can change. Anyway, so number of carbons, of course, like we'll say 3, 4, 5, or 6. Like if we have three carbons, so then it's like mono, di, tri, tetra, penta. That's how it goes. Like three carbons, triose, 4 tetros, 5 pentos, 6 hexos. That's how the Latin naming system comes. Well, now when it comes to glucose, there are 6 carbon atoms, C6H12O6. Right? There are 6 carbon atoms. So that is coming under the category of hexose. Disaccharide, 2 monosaccharide molecules join together. They are chemically bonded. 2 monosaccharide molecules combine, react together, and they form a disaccharide. Right. And oligosaccharides, that's going to be like more than 2, but not very much actually. It's like around 9, from 2 to 9 actually. You know that monosaccharide is just like the building block. It is just like the building block. So when we have 2 building blocks, we say disaccharide. 2 to 9, we say oligosaccharide. That's more than 2. If it is more than 9, beyond oligosaccharide, we call it polysaccharide. That's going to be a very long chain. Now starch is something like that. Cellulose is something like that. They are polysaccharides. Clear, right? Yes. This is about simple hydrocarbons. I'm sorry, simple carbohydrates, right? Monosaccharides. Like I said, disaccharide means combination of 2 monosaccharide molecules. These are some examples for those. Like I have selected some very familiar examples. Cake, candy, sugar, like basically sugar related products. That's about simple carbohydrates. No? Now let's come to complex carbohydrates. Just for you to have an idea. Starch, fiber, polysaccharides, right? Yeah, very long chains. That is coming under the category of complex carbohydrates. Now, as an example, we say now glucose and stuff, they are simple carbohydrates, right? Starch, cellulose, those very long very long carbohydrate chains, they are coming under the category of complex carbohydrates. Those are complex ones. Right. So these are examples. Right. Now we know about what simple carbohydrates are and what complex carbohydrates are. Right. So let's come to simple carbohydrates in detail. Now here, I have taken three examples for monosaccharides: glucose, fructose, that's the bottom one, and galactose. Those are the three. Now, if you look at this, you see in all those cases, if you count and see, there are 6 carbon atoms. 6 carbon is that is hex, right? There are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms, right? So 6 is to 12 is to 6. That means again, at the beginning you talked about 1:2:1, and the same ratio is right here. That doesn't change. 1:2:1. Carbon, hydrogen, oxygen. So here also we have the 6, 12, 6. 1:1, that ratio. But you see, even though we have the same number of atoms, same number of carbons, hydrogens, oxygens, basically we have the same molecular formula, the arrangement is different. They have arranged differently. Now you see, when you compare the glucose and galactose with fructose, is totally different. We have like hexagon-like structure is there in glucose and galactose, but that cannot be seen in fructose. It's like different shape. Even between, if you compare glucose and galactose, that is also that like looks more similar, right? That looks like almost similar, but that is again different, right? So arrangement of group is different. Right. So when the arrangement is different, the properties also are very different. What we do with glucose cannot be done with galactose. And even though we have this the same molecular formula fructose, that is going to be different. So carbohydrates, like these are the simple carbohydrates, structure-wise, they are going to be different. What do you think about the president's visit to Dubai? Will it be beneficial for Sri Lanka? Question? No. Right. All right. Remember, for these monosaccharides, there are two structures. One is the ring structure, which is what we see right now. And also straight chain structure also is there. So when we are asked to draw the ring structure, this is what we draw. And let me show the straight chain one. So this is glucose, that is fructose, right? So this is the straight chain structure. Formula is going to be the same thing. And here also these are the two isomers, glucose and fructose, right? Now, there's a difference. Let me show the difference between these two. Now, do you notice that right here we have OH group. OH means, right, let me talk about. Now, when it comes to organic molecules, this is very simple. Don't take it seriously. And you know, there are alkanes. Alkanes, we have carbon-carbon single bonds. Okay. As an example, we'll say petrol. Petrol is an alkane, right? That has 8 carbons, CH3, CH2, 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 1, 2, 3, 4, 5, 6, 7, 8, right? Alkane. Another one, alkene. Carbon-carbon double bonds, like this. We have carbon-carbon double bonds, right? Aldehydes, we have a C double bond OH, right? Alcohol, we have OH. Now in both the molecules you see we have OH, right? Everywhere you can see OH, that is OH group is present. That is alcohol group. Ketone, C double bond O in the middle. Both the sides are carbon. Now you see that one, the D-fructose thing, it has a C double bond O in the middle of the chain. That is a ketone group. But in D-glucose, we have C double bond OH at one corner, just like this. That is an aldehyde, right? So that difference is there. Right. In D-glucose, we have aldehyde group. Since we have aldehyde group, we call it aldose. Aldose. In this case, we don't have an aldehyde group, and OH is common for both of them. OH is common for both of them. In fructose, we have a ketone group, C double bond O. Same thing, C double bond O, right hand corner. Here also C double bond O, but not at a corner in the middle of a chain. Both the sides are carbon. That is a ketone. So we call it ketose. So you need to know aldose and ketose, right? The difference between aldose and ketose. Yeah. That's great. Thank you. Right, aldose and ketose. Okay. Aldehyde group, ketone group. So just have a look at that. So that is the difference we should know about that. And this L and D, so this is the D. So okay, let me talk about the other one also. There are two versions called, now we know the differences, like same molecular formula, but structure is different. We talked about the ring structure. Now we are talking about the straight chain structure. And depending, remember these different types of, this is a special group now, right? OH. So these are special groups, or we call them functional groups. They are functional groups. So the functional groups are different, right? Same molecular formula. Arrangement of atoms is different. And the functional groups present also is different. Right, so otherwise, there should be we should know the differences between the structures, right? Same molecular formula, C6H12O6, but different molecules we say. In what way they are going to be different, that we should know. In what way? They are similar only in chemical formula. That means number-wise, number of atoms-wise, they are similar. Other than that, arrangement is different, functional group is different, properties also are very different. Well, yeah, this is about the examples for functional, different functions. There's a lot. So we'll be learning little by little what functional groups are. If it is not clear, which one? Second one, alkenes. In one of my A-level classes, one of my students had the size of a like smaller book. I think he had a like smaller book than this, but managed to write everything. I was commenting on your that fellow used to come back all A-level, all organic conversions and all those stuff. He brings this size of a tiny book. I think half of the size of this, and just comes, writes everything with tiny font size and goes. I used to take pictures and upload on status and social media. So he used to describe that is cyberbullying. Which one? Make it alcohol. Legal. එතකොට මේ දෙකේ ගත්තට පස්සේ මේ පැත්තේ කොනේකේ තියෙන ඇල්ඩිහයිඩ් හරිද? එහා පැත්තේ තියෙන කීටෝන්. In addition to alps. නේද? Ketone. Okay. Yeah. Right. Technique. Right. And there's another chemical term that I need to introduce. This glucose, this like D glucose. So without just memorizing what D, like we should know what D is going to be. Right. So when it comes to right, another chemical term, chiral carbon. Very simple thing. We know carbon is in group 4 in the periodic table. So there are 4 electrons in the last chain level there. So that means carbon can form 4 bonds. Around the carbon, there are 4 bonds. Remember, chiral carbon is a carbon atom with 4 different groups around. Let's say A, B, C, D. So A can't be equal to B, can't be equal to C, can't be equal to D. Right? So A, B, C, D, they are not elements. So let me take some real example. HCl, Bri. Around this carbon atom, hydrogen, chlorine, bromine, iodine. In such case, this carbon atom is a chiral carbon. Okay, that is a chiral carbon. Now, if I take this CH3, CH, Br, CH2, CH3 in this molecule. So what if I draw this molecule by displaying all the bonds? Around this, we have 3 hydrogens. Around this carbon, we have a hydrogen and a bromine, and this big part. Around this, we have 2 hydrogens. Around this, we have 3 hydrogens, likewise. Now, for a carbon atom to become a chiral carbon, on the simplest requirement is there should be 4 different groups around. Right. So out of these carbon atoms, which one is the chiral carbon? If I label them from left side 1, 2, 3, 4. Okay, which one? First, second, third, fourth. Which one is chiral? Second one. Right. Why? Because around the second one, we have a CH3, a bromine, a hydrogen, and this big part. 4 different groups. Remember, these 2 are not going to be equal. Now, don't think like this is carbon, so this also is carbon, so it's equal. No, we consider the whole thing. The whole thing. So this is CH3, this is CH2, CH3, a big part, a bromine, and hydrogen. 4 different groups. So that type of a carbon atom is called as a chiral carbon. Right? Chiral carbon. So when we have a chiral carbon, when we have a chiral carbon, when we direct, so do you know about plane polarized light? Physics, up to what extent did you all go? Optic physics. Texas පටන් ගන්න තාම පටන් ගන්නපද plane polarized light වලට ගියාද? නෑ. හරි. Again, ලොකු එකක් නෑ පොඩි physics එකක් තියෙන්නේ. Then when it comes to this light, light, we know that we draw light in a straight line, but in real life, light is not a straight line, no. Isn't it so? Light is not a straight line, it is a wave. Light is a wave. So light rays, right? Whatever the light source, light rays, right? They are not traveling in a straight line. They travel in a wave. And wave like this. So a wave can go like this. So the plane of the light is this, vertical. Right? And another light ray can go like this. So the plane of the light is this. Right? And another one angle. Another one, another angle. Likewise, it's unlimited. The number of planes for light, when it comes to light beam, it's unlimited. That light is called as unpolarized light. Scattered. Focus name. I don't laser technology will tell about optic physics or right? Unpolarized light. The reality is only naturally available light. Unpolarized light. That is polarized name. Well, so can I erase? No. Then light is traveling in this plane, in this plane, in this plane, number of planes. ඕක අපි try කරොත් එහෙනම් පොඩ්ඩක් represent කරලා පෙන්නන්න මෙහෙම number of planes. We call it unpolarized light. ඒ ඔකම තමයි අර exchange කරන්නේ polaroid glasses වලදී ඒ ඉතින් physics වලදී කියලා කතා කරා right. ඔකම තමයි ඉතින් exchange කරන්නේ. Right. So what if I take a cardboard with a very thin vertical slit? හරිද? cardboard එක. එහෙම තීනි cut එකක් තියෙනවා. Now what is happening? The light rays which are coming only in this vertical plane will be allowed to pass through. අනිත් ඒවා මෙහෙම යනවා මේ හැඩයට යනවා කැපෙන. නේද? Right. So the vertical one I drew in red. So the red one will be allowed to pass through. අනිත් ඒවා යන්නේ. Right? The polaroid glasses වලට එද්දී ඕක මේ cardboard එකකින් කරන වැඩේ කරන්නේ silver plus වලින්. Right? එතන AG plus එතන වෙනම එකක් තියෙනවා. එතකොට ඒ කෙරෙන්නේ වෙනම එකක්. Right? This is battery low. Yeah, whose laptop is this? Charging it. Money. Right. 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 So this is plain polarized light. Only one plane. All right. Right. Okay, now you know what plain polarized light is. It doesn't naturally exist. We have to make it. All right, we have to make it. Basically, we have to filter it and make it. So this is plain polarized light. Let's say we take an organic compound. This liquid will say, oh, this is water. Let's say it's an organic compound, organic liquid. Right. If we direct plain polarized light, what is happening? Light is coming and from the other side, light is going, right? But remember, if we have a chiral carbon here, what will happen? Light will, without just passing through, light will be rotated to clockwise direction or anti-clockwise direction. Right? That is how we find out whether a compound has a chiral carbon or not. Chiral carbon තියෙනවනම් carrot එකනවා. එක්කෝ clockwise. එහෙම නැත්නම් anti-clockwise. පැහැදිලිද? Right. So let's say light is rotating to clockwise direction. We call it D isomer. D glucose. If it is rotating to the anti-clockwise direction, that is L version. L version. All right, anti-clockwise direction. Right. So those are the two. So then D and L letters are coming like that. Practically, we have to find out whether this particular substance is rotating the plane polarized light clockwise direction or to anti-clockwise direction. If it is rotating to clockwise direction, that is going to be D version. If it is rotating to the anti-clockwise direction, that is L version. Right. So then these are the L and D's. How this rotation is happening? So what is the story behind? Can I erase? We have to have chiral, no? Okay. HCl, we'll say this is a mirror. And then this is the mirror image. You know, we don't need big physics knowledge to understand that mirror image left and right changes, right? So this is the mirror. So in the mirror image, bromine will be on the opposite side, hydrogen will be on the opposite side from the original, right? So that is the difference. The two mirror images. Remember, one mirror, if we extract one mirror image from a solution, direct plane polarized light, that will be rotating the plane polarized light either to clockwise direction or to anti-clockwise direction. Let's say that is this mirror image, right? If you take pure other one, that will be rotating the plane polarized light to the opposite direction. Those are the two, right? So this is a mirror image story. What if we take both the mirror images into the solution in equal amounts, 1-to-1 ratio, 50-50? Then what will happen? One mirror image will be trying to rotate the plane polarized light to the clockwise direction. Other mirror image will be trying to rotate the plane polarized light to the anti-clockwise direction, right? Then both the efforts are going to be equal. Just like, let's say that, okay, right, we keep this bottle right here, I'm pulling this to my side, and you are pulling this to your side. Our efforts are equal, then this won't move. It will stay. Likewise, then the light will not rotate, it will just pass through. That is happening if we have both the mirror images. We call them actually optical isomers. Optical isomers, both the mirror images. If both are there in the mixture in equal amounts, there is no rotation. Right. So that is how this L and D notation comes. Right? This is glyceraldehyde. So D glyceraldehyde, L glyceraldehyde. The difference between these two, you see, now CHO, CH2O is same place. If mirror is right here, then left right changes. H is that corner here in the mirror image, H is this corner. OH, yeah. So those are two. Right. Uh, yes. So that is what we go to. That is L and D notation. Clear? Right. Sign up. I think the morning ones also have sign up. It's a very good. That's it. You want to then for the morning sign. Even can. Check it. Optical isomers. Right. So let me come back to the glucose molecule again. Right. So this glucose molecule, right, at the first place, is this aldose or ketose? The aldose and ketose doesn't have anything to do with this L and D version. So there is something else. We talked about what is aldose, what is ketose. So is this aldose or ketose? Aldose, because we have an aldehyde group, right? We have like quickly figure it out, like click that this is not a ketone, this is aldehyde, so this is aldose. Right. And we have 1, 2, 3, 4, 5, 6 carbon atoms. Right. And very clearly we see now this carbon atom is a chiral carbon atom. Why? It has 4 different groups around. On this one, this side OH, this side H, this side CH2OH, up this big part. With 4 different groups. So very clear which is the chiral carbon. The chiral carbon එකකටදී අර වගේ mirror images තියෙනවා. ඒකට optical isomers තියෙනවා. Right? So this is the D version. This is the L version. Right. So this is how we call like D glucose and L glucose. All right. D glucose and L glucose. Right. So then for glucose also we have 2 versions. Now we were categorizing, okay, carbohydrates, simple carbohydrates, complex carbohydrates. Simple carbohydrates, yeah, monosaccharides, we came to the monosaccharide level. Now in the monosaccharide level, yeah, even in monosaccharides we have aldose, ketose, right? Even when it comes to the aldose, we have D glucose, L glucose. Likewise, so we are in that D level. Okay, right. Right. Now, if we further discuss about that, these are the 2 same diagrams I copied from the previous one. Right. Now, this particular carbon atom is a chiral carbon. Okay, let's talk about this one. Right. This is a chiral carbon atom. But is this only the chiral carbon atom in this molecule? We know chiral carbon atom is a carbon atom with 4 different groups of different right. So what I'm asking is this only the carbon atom with 4 different groups around? Is this only the carbon atom with the is this only the chiral carbon atom? Right? No, right? Because now the qualification for a carbon atom in a molecule to be a chiral carbon atom, it has to have 4 different groups around that. Around this one, yeah, there are 4 different. Around this one also, 4 different. OH, H, this part, and this different part. So this is chiral carbon. This one, same way, a chiral carbon. This one, same way, a chiral carbon. This one, this is chiral or the top one. Right? Huh? තේරුණා? ඈ? ඒකට 4ක් නෑනේ 3යි තියෙන්නේ. හරිද? chiral වෙනවා 4ක් තියෙනවා. හරිද 3යි. ඒ නිසා ඒක chiral කතාවක් ඒකට අදාළ නෑ. යට මේක is it chiral or not? Why? ඒක 4ක් තියෙනවනේ. ඉබ්බට 4 different නෑ. නේද? දැන් මෙතන ගත්තට පස්සේ මේ පැත්තට OH මෙහාට H උඩට අර කඩි කෑල්ලක් තියෙනවා පල්ලෙහාට CH2 ඒක 4ම 4 විදියක්. හැබැයි මේ කාබන්ගේ උඩ එක කඩි කෑල්ල එක හරියි. එකක් OH එකක් හරියි. හැබැයි ඉතුරු දෙක H නේද? CH2OH. හතර වෙනස් හතරක් නෙමෙයි. දෙකක් සමානයි. ඒ හින්දා මේක chiral නෙමෙයි. යට මේක chiral නෙමෙයි. Basically, in terms of total number of chiral carbons that we have only 4 chiral carbons. Right. Okay. One chiral carbon produces two isomers. අර මම ඇදලා තියෙන example එකක් විදිහට. chiral carbon එක ගන්න මැදින් බ්‍රේක් එකකුවා අනිත් ඒකෙම අනිත් පැත්ත කරලා අනිත් පැත්ත ගන්නවා. Right? මේ දෙකක්. So this one produces another two. Likewise, so we can find the total number of different compounds, in other words, optical isomers, right? By finding the number of chiral carbons. Remember, to find out the number of different optical isomers, that is 2 to the power n. This is the formula. Why 2? Yes, 2 mirror images. What is n? The number of chiral carbons. The number of chiral carbons. Right? හතරක් තියෙනවා. එතකොට 2 to the power 4. All right. Right. So this is how we find how many different structures are there for one organic compound. They are optical isomers. Clear? Right. So when we are given some random molecule, we are not going to worry about it. We just look at the structure and we carefully count the number of, we carefully pick the chiral carbons, count 2 to the power that number is the total number of different compounds that we have. Clear? Right. Those optical isomers, remember, a synonym, another name for that, stereoisomers. Stereoisomers. And có gọi là đi gần so đấy. Của chị ơi. Stereoisomers. All right. Yes. Now, let me come to glucose. Right. Glucose is actually, I think that is the most familiar carbohydrate was, right? Glucose. Now, by now we know the structure of glucose, cyclic structure we know, and I think we know the straight chain structure as well. Right. Glucose, we know it is like, it's our essential energy source. Glucose is the one we learned about cellular respiration, right? So, like what happens, like when we take glucose, like we can buy glucose from the pharmacy, right? We eat glucose, so we drink glucose. Then what is happening? So, since it is in the monosaccharide level, it can be quickly subjected to cellular respiration, which we learned last week, and produce ATP. Right. So basically, this is called as this has a mild sweet flavor. We practically know that we all have eaten glucose, so we know that, and we call it as blood sugar. What is the reason for us to call that as blood sugar? Because glucose is a molecule, glucose is a version of carbohydrate, which is going to be involved in blood, isn't it? So when the blood glucose level goes up, here we are actually separately, we are talking about that related to hormones and stuff. Diabetes story, so that's a different story. Right. Okay, so glucose, and that is in the disaccharides as well. So all the disaccharides, they have glucose as one of the components. And in the polysaccharides also, we can find glucose. In the previous one, we had the structure, the cyclic structure of glucose. Now this is a straight chain structure. Remember, when we label the glucose, C6H12O6, that is formula. We number the carbon chain starting from now. This is coming under the category of aldose. One is aldose, the other one is ketose. So this is aldose. We give number one, so there are 6 carbon atoms. First carbon atom is the aldehyde carbon. Aldehyde may change the එකයි තියෙන්නේ. හරිද? ඒක තමයි number one. And we starting from that we go ahead. So 1, 2, 3, 4, 5, 6. Right. So that is how we label that. And L and D story we already talked about. Right. Well, ATP production we already talked about. This is how we use glucose for energy. Right. Have an idea about it? Now, carbohydrates. That is our main energy source. Just imagine, due to certain reasons, let's say that we didn't eat, right, in our busy life, there are situations that we don't get to eat. So we end up being gastritis, it's a different story. But though we don't eat, like our functions are not going to stop now. We need energy. Starting from breathing, it's energy. We walk, we talk, and we look everywhere. So energy is required. But we didn't eat. In that case, we don't have glucose. Then we don't have glucose, means aldose, no? Right, aldose. Then we don't have aldose. Right. Then what is happening? But we need energy. That energy has to be taken from fat. All right, lipids. So in the future, we are talking about how it is happening when it comes to the lipids. So anyway, when when the carbohydrates are not available, when aldoses are not available, this energy is going to be supplied with the aid of fats, basically. So in that case, our aldose requirement is not full. That is problem. Then there is an imbalance, that in the body, always there should be something in the metabolism is there to maintain the internal chemical environment of the body. What do you mean by internal chemical environment? The pH value and the concentration of every single thing. So basically, glucose concentration of everything has to be like in an optimum level, right? It can go like something can go pH value, a glucose concentration, or the water content. So something can go little high, there's a maximum range. It can go little low, there's a minimum range, it can't go beyond that. That's the way I say range for everything. Now, the moment this balance goes off, there are health issues. But anyway, in this case also, this aldoses and ketoses, there should be a balance. There should be a balance. Due to some food issue, right? When when aldoses are not present, when we don't have enough aldoses, that means aldehydes, what is happening? There will be excess of ketones, right? We know the difference between aldehydes and ketones, isn't it so? Right. So there is a balance. There should be a balance. The moment this balance goes off, ketones will be high. Right. There's an imbalance. Basically, this situation is called as ketosis, right? So then to avoid this situation, there should be minimum. This is a minimum required amount. 50 to 100 grams of carbs should be there in our day-to-day life. That should like a day requirement. Minimum, right? Minimum. If that is not available, the situation called ketosis arises. Right. That particular imbalance which I was talking about. Right. This is the situation that I was talking about. Diabetes. A very familiar term, right? What is happening? Okay, we eat. Food intake. And what is happening? The glucose, the blood glucose level rises up. Why the digestion is happening? Starch is broken down due to enzymatic processes, and the glucose is generated. Starch, is it soluble in water or not? Yes, sir. I rephrase the question. Starch, is it soluble, water soluble or not? Starch. No. Soluble. Starch. Rice. Can we dissolve that in water? DNA. Starch is insoluble. If starch is already soluble in water, we don't have to digest it. Right? The things that we eat, they don't dissolve in water. What are the things that we eat? Like rice, other living meat, fish, other living and even vitamins, there are water soluble ones and fat soluble ones. That is the vitamin name. A simple name. We'll go down. We have one living. So why do we do digestion to convert that into a soluble version? After we convert that into a soluble version only, it can be transported through blood. Okay. So in the digestion, the purpose of doing the digestion is to convert that to soluble version. Starch is not soluble. So that cannot be starch, cannot be dissolved in blood. That means can't transport through blood. We eat. Digestion happens. Glucose is the end result of digestion. And then glucose can be transported to different areas of the body through blood. All right. Why? Glucose is soluble in water. Right. Which is why after food intake, after we eat, the blood glucose level increases. Right. Glucose level, we eat, digestion happens, glucose is formed, that is dissolved in the blood. Right. Now the glucose level in the blood is right. But you know, there's a maximum concentration of glucose that can be tolerated by blood. Can't go beyond that. Right. So then what is happening? Insulin. By insulin is on. By insulin, the glucose level is going to be decreased. Right? Basically, at the right places, that is going to be deposited for further use in the future. Right. So then I was talking about the imbalance. So then what is happening? So then if we don't have enough insulin due to some health issue, then there will be imbalance of glucose. Right. That is the diabetes. The other version, opposite of hypoglycemia. Hypoglycemia. Opposite of diabetes. So there, in that case, the blood glucose level rises up. But here, blood glucose level decreases. Right? Blood glucose level decreases. How it is happening? Most of the cases actually, like either we haven't eaten enough, right? Even කාලා ඉද්දිත් ඇතිතරම් කාලා ඉද්දිත් glucose level එක අඩු වෙනවා. That means we have too much of insulin. Right? That is the other situation. So due to these two situations only, the glucose level drops down. You might have heard about this health situation, like sometimes, yeah, so there's lack of glucose that particular patient knows that glucose level goes down. එහෙම වෙලාවට අර දැන් sugar මොන හරි කාලා coffee එකක් මොකක් හරි කාලා ඒක සද්දාලා ආයෙත් පක් වෙන්නේ. නේද? අර දිනෝනේ right. එහෙම බලමු. ඒ glucose level එක අඩු වෙනවා. ඒකම ආයෙ ready වෙලා ඉන්නවා මේ situation. අඩු වෙනවා. ඒකට ඒගොල්ලෝ by experience දන්නවා. right. අමාරුයි මෙහෙම පණ නෑ එහෙම situation. ඒකට සද්දාලා සීනි ටිකක් කාලා එහෙම coffee එකක් කාලා ඒ ටික අක් කරගන්න ඕන. right. So this is the imbalance situation. එතන මේක හැමතිස්සෙම අපි දැන් diabetes වල දැන් අපි like glucose level වැඩි වෙන එක කතා කරන්නේ ඒක අඩු වෙන situation එකකුත් තියෙනවා. ඔය දෙකම තියෙනවා. right? Right. Okay. That's the previously we were talking about glucose. Now fructose. Well, fructose is a structure right at the bottom here. Fructose. It doesn't have this hexagon structure. When it comes to glucose, it has like mild sweet situation. Like this is when it comes to fructose, it is the sweetest one. Right? This is glucose we have in starch and stuff, those stuff. Fructose is a version that we find in fruits. Right? Fruits, honey based fruits. Okay. Right. And since this is very sweet, for the soft drinks, cereals, desserts, like those are the selling items, right? Fructose is the one which is used. And glucose ටිකක් දාලා ගොඩක් දාලා කරන්න තියෙන වෙලේ මේ අපිට fructose ටිකක් දාලා වැඩි කරන්න. ඒ artificial drinks හදද්දී glucose නෙමෙයි ගන්න. Fructose. ඒක වියදම more sweetest one. Right. That is fructose. Let's come to the next. Galactose. Galactose is this one. It's a bit hard when we look at the structure. It's a bit hard to recognize the difference between glucose and galactose, isn't it so? Hexagon, hexagon. CH2OH, CH2OH. ඒකත් equal. මොකක්ද තියෙන difference එක? මුල්ම difference එක ගන්න. තියෙනවා. What? Which one? The location of HNOH, HNOH, compare with this HNOH other side, HNOH other side, right here CH2OH, right? H is facing in both the carbons, H is facing towards CH2OH side. Here OH is facing towards CH towards, right? So that's the difference. Structure-wise, when compared with glucose. Right. Okay. So this is not highly available like glucose and fructose. Right. That's why I say that it's rarely found naturally as a single sugar. Other two both are present as single sugar, but not galactose. Right. Right. Monosaccharides understood, no? Right. All uncontrolled. Right. Let's come to disaccharides. You must be familiar with certain disaccharides. A disaccharide is always formed from the reaction between two monosaccharide molecules. Glucose, 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 fructose, glucose, galactose, lipase. It is the result of the reaction between two monosaccharide molecules. That is also shaky. But that's not practically happen, right? But, that. Oh, I get it. Yeah, I was wondering how come this is failing. Yeah, that's right. Good observation. Okay, so well, uh, well, so what I was talking about was that we do closest. Like what I was talking about was this is the reaction between two monosaccharide molecules. Remember, uh, there is a type of reaction called condensation reaction, right? Condensation reaction. In that case, now let me take a simple example for a condensation reaction. During the reaction between these two, this always goes with this hydrogen to form a water molecule as a byproduct. Then remaining part is added together. The C is getting connected with this O. The C is getting connected with this O. And rest of the part is there. All right. So basically, what has happened is a byproduct has been formed. Two molecules have been added together. Right? Two molecules have been added together. A byproduct has been formed. Such kind of a reaction is what we call a condensation reaction. Condensation. That is addition followed by elimination. Addition followed by elimination. Addition, yeah, added together. Elimination, yes, a water molecule is eliminated, removed. Neither. Right. So this is what we call condensation reaction. So what I was talking about was the reaction between two monosaccharide molecules. The reaction between two monosaccharide molecules. That is what we call, that is a condensation reaction because glucose plus glucose to form the disaccharide, byproduct water is formed. Right. So this is a condensation reaction. Well, the opposite of that, opposite cubic from the disaccharide, if you go back to the monosaccharide, then we have supply water. All right, we have supply water. Okay, that means during the reaction between two glucose molecules, water is released. Opposite, when a disaccharide molecule is broken to form glucose again, wood has to be supplied. So let's link that situation to the digestion. We eat starch, and starch has to be broken down into pieces into glucose, right? So the opposite of condensation, wood has to be supplied as a reactant. During condensation, water is released. By dilution, okay. So water has to be supplied. So, which is why we need water for the digestion, right? මේ reaction එකට water reactant එකක් විදිහට ගන්න තියෙන නිසා. Without water, regardless of like how good your food is, without water digestion is not happening. Right? So water has to be there. Right. Okay. So that is about how disaccharides are formed and how this happens. Okay. Maltose. Look at the diagram. Maltose. We have two molecules. All right. We have two molecules. Two glucose molecules. This molecule and the other molecule. Those two molecules join together and forms a water molecule. On the board, what I have drawn is not a glucose molecule. I just wanted to introduce what a condensation reaction is. Right? So here, maltose molecule. It's a combination of glucose and glucose. Glucose molecules react together. It is a condensation reaction. Water is released as a byproduct. And this is the product form. Right. So here, there was before the reaction, left side, there was OH here. Right side, there was OH here. Then OH from one, H from the other one, are used to make the water molecule. Right? You need to click that chemical reaction happening here. That's how the byproduct water is formed. Right. That's why the remaining oxygen is there. I mean, but it OH තියෙනවා. එහා පැත්තේ OH තියෙනවා. බෝඩ් හදන්න ඕන වෙන්නේ H2 O 1යි. එතකොට O එකක් ඉතුරුයි. ඒ ඉතුරු එක තමයි. හරි? Right. So that is the maltose molecule. Right. Now, this is another example. Right. In that case, the molecular structure is a bit different. We say that is zigzag, flipped over, right? That's connected in a different way. So that is yeah, you clearly see straight away connected. And this is and the angle is connected. It's a way that it is reacting. Right. Yeah, so this is how basically a disaccharide is formed. So this is maltose. Let me show that reaction. The condensation reaction. Right. So this is much more clear, right? This is the link. Maltose molecule. Understood? Okay, no? All right. Right. Next one, we'll go to sucrose. Sucrose, we know. Just like glucose, we know. Another, like, just like your family with glucose, your family with sucrose as well. Maltose, the previous one which we're talking about, it's the reaction between the glucose molecule and another glucose molecule. Fructose, that is the product of the reaction between a glucose molecule and a fructose molecule. Available in fruits, vegetables, grains. Well, from sugarcane, that is the disaccharide that we extract. We have the brown version and white version. Sugar, when it comes to the brown one and white one, what is the difference? Glucose and fructose. Anyway, molecular formula that is equal, no? Reaction between these two. C12, H22, O11. Plus H2O. Why plus H2O? Condensation. Condensation. So plus H2O. Right. So what I asked was brown and white version. So what is brown sugar? What is white sugar? What is the difference between those two? And ඒකේ difference මොකක්ද? brown එකයි white එකයි නෑ. දැන් අපි දැන් හිතන්න full CD එකක් කියලා CD එකක් ආවනේ. ඒ සුදු CD එක දුඹු CD එක කියන. ඔය දෙකේ මොකක්ද difference එක? මොකක්ද difference එකක් නැද්ද? සුදු එකද brown එකද ගන්න? දින එකක් අද ඔව් මතක තියාගන්න sugar cane industry එකෙන් උගස්මින් අපි ඔක මේ industry එකට තියෙන පැලවත් තියෙන right එතකොට sugar cane වලින් ඔය industry එකට අපි extract කරලා එතකොට මේක සම්පූර්ණ මේ plant يعني raw material එක plant එකක් දැන් plant එකක් ගත්තම ඕකේ තියෙන්නේ sucrose විතරක් නෙමෙයි හරිද ගොඩක් තියෙනවා එතකොට මේකේ original color එක brown හරිද original color එක brown එතකොට මේ brown color එක තියෙන්නේ අර ඉතුරු plant materials වලත් එහෙම එක්ක. අපි දැන් lab එකේ reaction එකකින් අපි sucrose හැදුවොත් ඒ හැදෙන එක සුදුයි. හරිද? ඒ හැදෙන එක සුදුයි. හැබැයි අතන අපි industrially අර මේ උග්ගස් වලින් හදන sugar ගත්තොත් ඒක සුදු නෑ ඒක brown. හරිද? ඒක brown. ඊට පස්සේ දැන් ඕක ආපහු ගත්තට පස්සේ අර මේ කෑම හදන කේක් හදන අරෝගියම ඒ සීන් වලට ගත්තට පස්සේ බ්‍රවුන් මැච් වෙන්නේ නැති අවස්ථා තියෙනවනේ. ඒකෝ ඒ කලර්ස් උත් එක මැච් වෙන්නේ. ඒතකොට එහෙම එකකට එතකොට තමයි මේ වයිට් කරලා ගන්න බ්ලීච් කරලා පොලිෂ් කරලා බ්ලීච් කරලා ගන්න. එතකොට කෙමිකල්ස් කන්ටෙන්ට් එකකින් අඩු වෙන්නේ බ්‍රවුන් එක. වයිට් එක නෙමෙයි. වයිට් එක පොලිෂ් කරලා බ්ලීච් කරලා තමයි වයිට් කරලා. It's best to buy the brown one. Right? Clear? Yes. We'll come to lactose. Lactose, that's in milk. The reaction between glucose and galactose. Right. So glucose and glucose produces maltose plus water. Right? Glucose plus fructose produces sucrose and milk. Glucose plus galactose produces lactose and water. Right? So this is the bond between the two molecules. Right? So this is lactose. We call it milk sugar. That is the disaccharide present in milk. Right. Do you know about this health issue? Lactose intolerance. Then what? What is it? What happens? We know some people they can't drink milk, right? There is that situation is what we call lactose intolerance. Well, what exactly is happening in lactose intolerance? Well, now lactose molecule, right? Go back to the previous slide. This is a molecule, right? This molecule has the ability to attract water molecules, right? It attracts water molecules. When it attracts water molecules, what is happening? You drink lactose, right? Now it is inside. Lactose molecules attract water molecules. Then what is happening? The lactose molecules attract water molecules. It's now the water, the availability of water in the intestine is going to be less. Now what happens? Without water, digestion doesn't happen. Enzymes can't do this alone, right? Enzymes are the ones like responsible for the digestion. True. But without water, that cannot be done. So water has to be there. Water has to be there. Right. So then think about just having enzymes in this intestine to do the digestion. Just imagine intestine is okay, intestine is there and food is there. Enzymes also are there. But water is not there. It's just like having fantastic with us without bullets. Something like that. All right. So water has to be there. Without water, now what is happening? Lactose is absorbing, attracting water molecules. Now availability of water for the digestion becomes less. Right. Now what is happening? There will be undigested lactose. There will be undigested lactose. Right. Okay. It is undigested means now it's available as food yet. Why? Digest and now food will be then what is happening? That is going to be food for the bacteria which lives in this intestine. Right. Now, in such situation, it is producing acids, gases. How? Because of the digestion of bacteria is using that as a food and do the digestion means that we can't take any benefit of that. It's beneficial for the bacteria. Right now, it is releasing acids and gases. Then our body rejects that food, rejects that meal. Right. So that is the situation. All right. So we'll end up with diarrhea. So the stomach is paining, right? So this is what we call lactose intolerance. Clear, right? Okay. Right. So this is more about lactose intolerance. Clear, right? Yes. Right. Now we know about, we talked about all the three disaccharides. Right. Now let's see in the digestion, how do we break those disaccharides, which we call hydrolysis. Remember, hydrolysis is, by definition, hydrolysis means breaking a bond by splitting a water molecule. What bond I am talking about breaking? Here, this is the new bond form from the reaction between the two monosaccharide molecules. In hydrolysis, what is happening? That bond is broken to make the monosaccharides. That is hydrolysis, means breaking a bond by splitting a water molecule. Hydrolysis is breaking a bond by splitting a water molecule. Basically, the water molecule breaks, and it is water molecule splits, and it's by using that it is breaking the disaccharide molecule. Right. So monosaccharides, disaccharides. That. Now let's come to complex carbohydrates. Complex carbohydrates. Those are very long carbohydrate chains. Monosaccharide, that is a building block. Disaccharide, combination of two. Polysaccharide, yeah, so very low ones. Those are complex carbohydrates. That's what we are going to talk about. Right. Well, there are two main ones, glycogen and starch. Glycogen is found in animals like us. Starch is found in plants. Remember, both of them are completely formed from glucose. So if we take a glycogen chain and break, we get glucose. Take a starch chain that's coming from plants and completely break it, we end up in glucose. So glucose is a building block for both of them. Right. So polysaccharides, glycogen, starch, and fiber. Right. That is also the carbohydrate derivative. Well, so let's talk about how it is happened. Look at this. Right. Look at that chain right on top. That is amylose, a very long chain. A very long chain. So in this case, 1, 2, 3, there are 5 building blocks are there. Right? 5 building blocks are there. Amylose. It's a very long chain. Right. A complex carbohydrate. Well, where do you find this amylose? In plants. That's a plant's version. Right. Okay. Just have a look at that. That's amylose. Let me take another example. This is amylopectin. Another example, amylopectin. Right. Amylose is a straight chain. Now, do you notice that in amylopectin, we have a branch as well? Right, this is a straight chain. And there's a branch. All right, there's branch. That's amylopectin. Another example, glycogen. Glycogen, of course, is not found in plants. Like I said earlier, that is found in animals. And this is also not just a straight chain. It is a branched one, right? It's a branched one. Now, this branching, how it is happening, how this branching is happening. So depending on that only, we have different types and different leaves. And the place where it is linked as a branch, that is also going to be different. Right. Animal version. Clear, right? Right. Another example, cellulose. Cellulose. That is, again, this is a plant version again. Cellulose. Cellulose, just wood. This is actually processed wood, like just normal wood, right? That is cellulose. I'm using here, it's linked in a different way. The function of cellulose is it is giving the strength to the cell wall of the plant. Animals, when you compare the animal cell and plant cell, now plants, the wood, that is strong, right? Animal cells, like rather than the animal cells, wood is like very strong. So the strength is given, like so the cell wall is given the strength because of this cellulose, right? Plants version. Now we'll come to animal version. Glycogen. That's completely out of plants. It's totally when it comes to animal tissues like meat and all. Again, combination of glucose. As you already know, if we break this glycogen chain, then energy is released. Energy is released. That is hydrolysis reaction. Okay. Right. This is a most common carbohydrate to us. We eat starch, isn't it so? Right. Starch is like it's stored in the plant cell, and by hydrolyzing starch, we get glucose. Then glucose is subjected to cellular respiration to generate ATP. Well, more about starch. Right. Okay. Now we know about the theory side of carbohydrates. Now let's see about the identification test side of these compounds. Right. Well, well, there is a solution called failing solution, Benedict solution. And there's another solution, tolerance region. Remember, in Fairings and Benedict solution both, we have copper 2 plus sign. You know, copper sulfate anode, right? That is blue in color. So wherever we have copper 2 plus, that is blue in color, right? In failing solution and Benedict solution, so those are just remember the names, okay? Those are the regions. Failing solution, just a region. Benedict solution, just a region. Both the cases we have copper 2 plus sign. And there's another region called tolerance region that has silver plus sign. Right? What is happening during the test? We can identify that during the test, silver plus is becoming silver. Is silver. Then during the test, so as a result, we can see silver is a metal. Silver is a metal. Then if we do the experiment, we'll say we are doing the experiment in this, then what will happen inside this during the reaction? Silver is formed. Then silver is a metal that is going to be deposited on the inner wall of this bottle. So from outside, we can see a silver mirror. Right, that silver color from outside, we can see that, right, that is a positive result. That is a positive result. Well, the other one is Fairings test, Benedict's test. Both the cases we have copper 2 plus sign in solution. Just like in the tolerance test, silver plus is becoming silver. Likewise, what is happening here is copper 2 plus becomes copper plus 1. Just like silver plus becomes silver, copper 2 plus becomes copper plus 1. Actually, in that case, it is forming a red-brown precipitate. That is a positive result. It forms a red-brown precipitate. Right. This test is positive. These we talked about three: tolerance region, tolerance test, failing test, Benedict test. This is positive for reducing sugar. Sugar, of course, like all the like sugar types, they are not reducing sugar. Reducing sugar, that is positive. When we talk about sucrose, sucrose, it is a disaccharide, true, but it is not a reducing sugar. Sucrose is not going to be positive for the test. These three tests are positive for reducing sugar. These are the diagrams of those solutions. Benedict solution, Fairing solutions we were talking about, those are blue in color. And this logo solution region, that is iodine. We can identify starch by using iodine. Iodine is giving a blue-black color when we add that to starch. So starch and we identify. Yeah, that's the iodine solution. When starch is present, it is giving, this is the positive result. I don't think that color is that visible there. So that is blue-black color is coming. Starch iodine combination. It's giving blue-black color, like very dark color. When it's, this is a diagram of basic solution, like the solution. This is how region comes. It's a true solution. I was talking about that red brown precipitate. So this is how that red brown precipitate appears. Right. So that's how it goes. Right, carbohydrates. So these are the things that you need to know, and the carbohydrates and the is and classification monosaccharide, disaccharide, polysaccharides, and simple carbohydrates and complex carbohydrates. So those stuff. So it is not hard like glycolysis and Krebs cycle and stuff, which is easy. Right. Okay. Right. Time for the questions. Anything which is not clear. Anything which is not clear? All under control. So far, no doubts. Is that so? It's identified also, right? Where is it? Recording, do we have to stop? Yes. Leave. More. Camera can't have it. Oh, yeah. Yeah.
Say you recorded questions.
Hmm.
Stop it.